Okay, well, thanks for showing up. My name is Roel Jansen, and about a year ago I sent an email to the GNU Guix development mailing list asking for whether somebody knew a way for me to do an internship that was related to GNU Guix or GNU Guile. And I was lucky enough that Piotr Prince replied to me, and I found a really interesting place at the UMC Utrecht. And one of the things I worked on during my internship in the last weeks of it was something called workflow management. And to understand the concepts of workflow management that I'm going to try to address. Oh, yeah, somebody signed me that I should talk louder, so I'll try that. Yeah, so what I'm going to show is I've implemented a couple of record types on top of GNU Guix's infrastructure for package management, and this thing works. And to understand what I'm trying to achieve is that I'm now working at an institute where we are doing a data analysis, and so we have some initial data set, the yellow node here. And then through running programs on it, we try to extract information from it, filter the information, or try to get useful research results from it. And eventually we want some undeniable proof for our theorem or for whatever. And if you look closer into the nodes labeled A to N, we can see that these processes can be really simple, like a grep for some information out of the file, or a little bit more advanced, running an R script or some other foreign language to Guile. I know. So what we're trying to do here is we're trying to make an easy way to run these things, either serially or in parallel. And what I'm trying to capture is a workflow, which is, for me, it's just a set of processes that we should run to get from an initial data set to the undeniable proof. And I am not including the data into the whole process. That's just something you put in and get out. And actually you can, if you look at real world situations, it's more common that you don't get a serial process going from A to N, all simple steps, but more likely you can run a couple of things in parallel. Like you see from the node A to, we can run 3 processes at the same time, and at some other occasions some process needs to wait for input from various other processes. And at that point, if you would do this with a shell script, it could become pretty complex, and it gets really interesting if you can run things in parallel on multiple computers. That's also something pretty hard to do with shell scripts, I guess. So what we have at UMC Utrecht is we have multiple computers all connected to a single storage, and this storage is actually quite expensive. So it's a 2-step thing. So we have storage that we can actively use that's connected to these compute nodes, but we also have storage that's used for archival purposes and backups, so that when a hard disk crashes or when more hard disks crashes, then this data gets lost, but some more valuable data won't get lost. That's important to note. For if we want to run processes, we should store this data not inside the GNU store, in the Guix store, but outside of it, so we can archive it. So to run things on multiple compute nodes, we have this infrastructure, it's called a job control system, and you basically pass it a shell script with some additional syntaxes like how much memory do you want to allocate and how much time do you need it, and then it'll run the commands in that bash script. Yeah, really, bash, not shell, just bash. So that's a bit unfortunate for GNU Guile users, right? But we'll get to that. And then the job control system can queue these on these compute nodes or run them all together. What I've created are two record types, and this is the first one. It defines a process, which is the A to N nodes, and it looks kind of similar to a package, but only a little bit more simple. So it has a name and a version and a description and a synopsis. Description fell off the page, not too bad. But what's more interesting here is that a process can have a package input, which are Guix packages. So that should look familiar. But also it can have data inputs, which can be anything you like. You can create a simple list of samples, or just a string or a number, or you can make some more advanced things like an associate list with multiple items, which you will later use in the procedure. And it has some runtime complexity specification in both space and time. With this information, we can say something about how long the process will run. And as you can see, this is just scheme code. So you could include the size of a file and then say, okay, it needs twice the amount of RAM of this file size to compute. So something you can test out and try. And then with this information, it's all pretty basic, but then there's this procedure that actually executes the commands in the shell script. And this procedure is, and I hope this looks a bit familiar because it's been addressed in a couple of talks before me. It's a G expression, and it's basically the quasi-quoting, but then in a Guix specific way. This G expression, you can directly input packages from Guix, and then the nice thing about this is that when you try to run the procedure, when you turn it into a derivation and then later output the actual script that rolls out of this, it automatically builds the packages for you that you're actually using. So that's really useful. And then now I want to get to the second type. So now we have these processes, but how are we going to connect them all? Now we need a different type for that. That simply, again, it looks quite familiar, I hope. There are two things here that are interesting, the restrictions and the processes. So processes is just a list of all the nodes that you want to use in this workflow. So these are just the processes you defined earlier. And the restrictions should be read in a way that you say the first depends on the completion of the second. And that's a really nice way. So from these restrictions, you can determine its dependency graph, basically. And that's all to it, because with this information, we can now construct a dependency graph of processes that we've defined using G expressions. So how that works is that you have this process definition, and then you turn it into a derivation, which will end up in the Guix store, right? And when you build that derivation, it will build the dependent programs for you, and it will return a job script for you. And that job script is something you can pass to the job control system that then will distribute it to one of the compute nodes in your cluster. That's basically the entire idea. So the job script, of course, uses the programs that you've built earlier. The derivation did that for you. So there's one thing to note here, that in order for the job script to actually work on a different computer, it needs to have access to the programs. So it kind of depends on a shared storage for all your compute nodes. Yeah, maybe you should address that, I don't know. For us it works, but maybe for others it doesn't, I don't know. So I probably needed to write some tutorial or something, because I think the easiest way to get down to how this works is to just try it out. And I did that. So you can find it on this webpage. You can download the source code for my project. I actually forked Guix for this, but I want to include it into the upstream distribution. And I hope when it's stable enough that one of the Guix maintainers will allow me to introduce the workflow management bits into Guix upstream. Yeah, and if you have questions after this talk, or when you're at home and you want to ask a question, you can always email me. Yeah, so I'd like to acknowledge a few people. Piotr Prince first for letting me do this internship. Joep de Licht, he was also involved in my internship, and Ricardo Worms and Ludwig Cortez for helping me. Ricardo gave me some very useful feedback on what the record types should look like. And Ludwig Cortez, yeah, you're just a great inspiration, right, for almost anything. So, yeah, and you probably see me around in the GNU Guix development mailing list and the IRC chats. So, thanks for all the help, for those who helped me. So, yeah. So, are there any questions?
So, Roel, is there? I mean, this workflow idea is very interesting because it brings in the concept of using external data paths.
Right.
But you know, would there be some way of integrating this with the Guix track management system that we actually can execute jobs or something?
Yeah, I thought about that, but I even tried that. But the problem, so the question is, can we integrate the data with the Guix package management system? So I suspect that what you want is to execute the jobs immediately and then put the results into the Guix store, right? I thought about that, and my first version did that, but we ran out of space pretty quickly on the Guix store, and then we had this problem, like these are really huge data sets that we're processing. We're talking hundreds of gigabytes here per data set. And if you all put that in the store, then you probably end up saying, hey, my GNU store is pretty big, let's garbage collect it. And at that point, you could lose the results of your research. And you don't want that, so we're looking into letting some other system manage the data and archive it for us. Actually, there's already such a system available. So why not let that system handle the data management part and let Guix handle the a package deployment and handle the generation of the scripts so that it can be executed easily with existing job control systems. So yeah, it's a trade-off, and I don't know what's the best way to go here, but this is actually the only way it works for us. So.
From own experience, I can say that having a shared store is sometimes a little challenging. Would it be possible to combine what you've done, creating the job script, with what Piotr did, which was creating relocatable binaries, so that users can use Guix locally together with your tool, and then serialize the complete environment, push that over to the cluster. So then you wouldn't have to have a shared store. Maybe I'm wrong about this, but it seems like this would be possible.
Yeah, so if I can repeat the question in a bit more shallow way, would you like to run or push a container with all the deployed software to some other machine, then run your data analysis there, and then get the results back? It's basically what you're trying to do, I guess, to avoid a shared store system. I think we can do that because we can spawn containers with Guix. We can pack everything into a container, right? But I also seem to remember that that's not really the way we want things to go, right? Because then we're kind of giving up on the idea that we can efficiently distribute software and use it, right? So maybe it's easier to, I don't know, fix your shared storage system, because I don't know. but we can definitely look into it, and I would like to look into making a like an app bundle. Yeah, I know it's not a great word, but kind of like a container. Of course, we do that with Guix, not with Docker or something, and then we can distribute that to a compute node and run it there.
So we have two types. Would it be possible maybe to have another type that you could use within the workflow that possibly read data in and out of the store? That might mean that you can actually use both of those approaches, or either of them, all at the same time.
Sure. Yeah, I'd like to welcome you to write it. I don't know how it would look exactly, but yeah, maybe. Could try that.
Could you just say a few words about the existing tools that are being used, for instance, at your institute, and how it improves on it, and what the reception is also for the tool?
Okay, so the existing tool we have is Perl. So we're looking into workflow management systems, and we tried the common workflow language. And I was the first to try it, and then I tried the Hello World, and then thought, I really need a programming language for my workflow definitions to be flexible enough to address every case. And that's exactly what the common workflow management language is developing into. They included JavaScript into their declarative types, and so yeah, they're including a language into there. And I think that the best language to do this Guile, with some Guix package management, because that's very important for us. So the reception is that nobody's writing workflows as of yet at our institute, because they're writing Perl code and it works. We have these huge files of Perl code, 700 lines of code is like the basics, and then comes the error handling and the stuff around it. But we're trying to get started on writing workflows in this way or some other workflow language. But then, first you need to solve the deployment problem of software, and Guix is the only thing doing it right, I believe. So that leaves this workflow language as the only language that addresses the full thing. Right? So I'm pretty confident we're going to use it. Any more questions? Okay, then I would like to thank you.